What if I told you that everything you know is a lie? The world around you, the chair you're sitting on, the air you breathe, the stars twinkling in the night sky are not quite real. Imagine that this entire universe is nothing more than an elaborate computer simulation. It's like science fiction. You might dismiss it. But what if clues are hidden all around us, embedded in space and time? What if the laws of physics are actually code? This isn't just late-night musing. It has fascinated brilliant minds. We think of reality as tangible. We trust our senses. We believe what we see, touch, and feel. Our senses are easy to fool. Optical illusions, dreams, virtual reality all show how convincing a fabrication can be. How can we be certain this is the genuine article? Are we characters in someone else's advanced video game, living out a pre-programmed life? The proposition is staggering. It forces us to question our basic assumption. One true reality. If it isn't, then every discovery, every historical event, every personal memory could be part of a script. The feeling of the sun on your skin might be simulated heat. It's a dizzying idea. It can make you question your sanity. But science pursues unsettling ideas. Those questions lead to breakthroughs. We look outward to the cosmos, distant galaxies, exploding stars. Maybe the biggest revelation is inward, the nature of existence itself. Are we biological beings evolved on a rocky planet? Or informational constructs running on a cosmic supercomputer? We are on the verge of a paradigm shift, a leap of faith like Neo, and choose which pill we want to swallow. The idea that our reality might be an artificial construct found its modern voice through a philosopher named Nick Bostrom. In 2003, he published a paper that laid out a compelling argument, not a wild guess, but a logical exercise. Bostrom proposed one of three possibilities must be true. First, civilizations like ours almost always go extinct before they can develop hyper-realistic simulations. Second, advanced civilizations lose interest in creating such simulations. Third, we are almost certainly living inside a computer simulation right now. Think about it. If civilizations can create simulated worlds, they would likely create many of them. This idea has deep roots in philosophy and decades of science fiction. The Matrix brought the idea to the masses. Tron showed programmers digitized inside their creations. Ready Player One imagines a society living inside a vast, shared virtual universe. These stories act as thought experiments about technology and ethics. Bostrom's argument hinges on projecting our technological trajectory. We went from Pong to sprawling photorealistic open worlds. Now, imagine projecting that progress forward thousands or millions of years. An advanced civilization could create simulations indistinguishable from base reality. The beings inside wouldn't know. They'd think their world is real. Why run ancestor simulations? For scientific research, to study societies, for entertainment, the ultimate immersive experience, or for reasons beyond our comprehension. The key takeaway is statistical. Countless simulated universes for every one base reality. The odds then favor us being in a simulation. It's a sobering thought. We might be a copy of a copy, living inside someone else's experiment. How could a universe as vast and complex as ours possibly be just information? The answer may lie in one of the strangest and most successful theories in all of science: quantum mechanics. On the cosmic scale of planets and galaxies, the universe seems to follow predictable rules, the classical physics of Newton-Einstein. But when we zoom in, way down to the subatomic level, electrons, photons, the rules change completely. Here, in the quantum realm, things don't have definite properties until we measure them. An electron doesn't have a specific position. Instead, it exists in a cloud of probabilities, a wave of potential locations. This is where things get truly bizarre. The very act of observing a quantum particle seems to force it to choose a state. Before you look, it's everywhere and nowhere at once. When you measure it, its probability wave collapses, and it snaps into a single, definite location. This observer effect is one of the deepest mysteries in physics. It suggests that reality, at its most fundamental level, isn't a solid, pre-existing thing. Instead, it seems to be something that is brought into being through the act of observation or interaction. It's as if the universe is waiting for a conscious observer to render the details on demand. This strange behavior has led some physicists to consider a radical idea known as digital physics. This school of thought proposes that the universe isn't just described by information, but that it is, in its essence, information. Every particle, every force, every law of physics could be the output of a computational process. The universe in this view is like a giant computer. space-time are not smooth and continuous but are made of tiny, discrete units like pixels on a screen. If you could zoom in far enough, you might find the fundamental resolution of the universe, a smallest possible length known as the Planck length. If reality is made of these discrete units, it would mean that the universe has a finite amount of information it can contain. The bizarre rules of quantum mechanics and the apparent pixelation of space-time might not be mysteries at all. They could be the telltale signs of the underlying code. The legendary physicist John Archibald Wheeler summed up this entire line of thinking with a simple, elegant phrase, "it from bit." So what did he mean by that? He was proposing a revolutionary new way of looking at the universe. The it represents everything in the physical world, every particle, every planet, every galaxy. It's all the tangible stuff we call reality. The bit is the fundamental unit of information. A yes or no answer, a 1 or a 0. Wheeler's idea. Every it derives existence from bits processed at the deepest level. Think of it like a character in a video game. That character appears solid on screen. It can run, jump, interact with the environment, but at its core it's not flesh and blood. It's bits of information. Its look, abilities, and rules come from the game's code. Wheeler suggested the universe might work the same way. An electron isn't a tiny solid ball. It's the result of yes or no questions being answered. Is it here? Is it spin up? Those binary answers, bits, conjure the electron. This changes how we view physics. Laws like gravity, electromagnetism might not be fundamental. They could be algorithms, computational rules the cosmic computer follows. So discovering a law may be reverse engineering source code. Physicists become cosmic hackers decoding the programming language of existence. If true, information is more fundamental than matter and energy. Before the Big Bang, maybe a sea of pure information, a blank computational slate. The Big Bang could be the moment the program was run, when bits started processing into it. Our cosmos could be the output of a colossal computation. We are living in the output of a cosmic information processor. As you might imagine, not everyone in the scientific community is ready to embrace the simulation hypothesis. For many physicists, the idea, while fascinating, straddles a dangerous line between science and pure philosophical speculation. A core principle of the scientific method is that a hypothesis must be testable. It has to make predictions we can verify or falsify through experiment. Critics argue the hypothesis may be fundamentally untestable. How could we design an experiment to prove we are or are not inside a simulation? The arguments against it are compelling. Physicist Lisa Randall, for example, has expressed skepticism, saying the odds are effectively zero. She and other critics say the case relies on many assumptions about how future civilizations would behave and what their motivations might be. We project our own desires for gaming and for research onto hypothetical, super-advanced beings. It's a very human-centric view. Who's to say they wouldn't find ancestor simulations boring, unethical, or a complete waste of computational resources? Some argue clues like the pixelation of space-time at the Planck length or the observer effect in quantum mechanics are not evidence of a simulation. They might just be fundamental features we don't yet understand. Attributing them to a simulation is a God of the gaps move. Where we have gaps, we insert a simulator. It's an easy answer but may not be the right one. Science fills gaps with evidence and theory, not an unknowable programmer. Still, proponents search for tests. Some scientists propose looking for glitches, small inconsistencies in physical laws that might reveal a computational substrate. For example, high-energy cosmic rays might behave slightly differently if they're bumping against a simulated space-time grid. So far, no such evidence has been found. The simulation idea is tantalizing and mind-bending, but for now it sits at the edge of scientific inquiry, waiting for a test that could confirm our wildest digital dreams or bring us back to solid, unsimulated ground. If we do live in a simulation, the implications are truly mind-boggling. Let's start with the idea of glitches in the matrix. In any complex computer program, bugs are inevitable. No matter how sophisticated the code, errors can occur. In our reality, a glitch might not look like a cat repeating its actions. It might manifest as a subtle violation of the laws of physics, a momentary flicker in a physical constant, or a particle appearing where it really shouldn't be. Events like déjà vu, or unexplained phenomena, often dismissed as tricks of the mind, take on a whole new meaning. Could they be the system momentarily lagging, or maybe an error in the code of our world? The idea also opens the door to the concept of nested simulations, kind of like a set of Russian dolls. If an advanced civilization can create a realistic simulation, what's to stop the simulated beings inside from eventually developing their own technology to create their own simulations? This could lead to a potentially infinite hierarchy of realities, each one a simulation created by the civilization in the level above it. We could be living in a simulation within a simulation within a simulation and so on. Where does it end? Is there a base reality at the very top, or is it simulations all the way down? This leads to another profound question. What about our creators? If we are simulated beings, then we were created by a higher intelligence. This doesn't necessarily mean a divine being in the religious sense, but rather a civilization of programmers, engineers, or maybe even a bored teenager in a higher dimension. This civilization would be, for all intents and purposes, our gods. They would have the power to alter the laws of physics, rewind time, or even shut down the simulation entirely. The thought that our entire existence could be terminated with a single keystroke, the ultimate Ctrl-Alt-Delete, is both terrifying and humbling. And so we arrive at the ultimate question, the one that lingers long after the scientific debates have quieted. If our universe is a simulation, a grand piece of cosmic code, then who or what wrote it? Who is the programmer? This question takes us beyond the realm of physics and into metaphysics and philosophy. Are our creators biological beings like us, just far more advanced? Or are they post-biological artificial intelligences beyond physical bodies? The possibilities are limitless. Maybe the simulation wasn't even intentional, maybe it's a byproduct, a student science fair in a higher dimension. Imagine a young being running a galaxy formation simulation. Conscious life spontaneously emerges. To them, we're an unexpected data point. The purpose of our existence could be accidental. The meaning we search for in art, in science, in religion, an emergent property of someone else's program. This forces us to confront our cosmic significance. For millennia we've put ourselves at the center, physically, then philosophically. The simulation hypothesis is the ultimate demotion. It suggests we may not be part of the real universe. But does that diminish our lives? Does it make love any less meaningful? Joy any less meaningful? Discovery any less meaningful? The experiences are real to us, the pain we feel is real, the beauty of a sunset is real. Even if it's rendered pixels, our awe is genuine. We're left staring into the great unknown. Whether base reality or simulation, the quest for understanding gives our existence meaning. The search for the programmer is a noble, profound purpose, and who knows what you might find.